All right, so what we're going to talk about is a solution when no solution exists. Okay, so again, there's no solution for ax equal b. It's not solvable. So what we're going to do is we're going to find an approximate solution. So the approximate solution is going to be x hat, and I'll explain why we call it the least square solution later. But x hat, you know what x hat is. So a solution for ax equal b would be the x, right? So the solution, if there was one, would be the x. So there is no solution. So x hat is going to be the closest to solution for this unsolvable equation. All right. So ax hat we're going to call a solution, an approximate solution to b, right? Because it's a times the x hat that solves and gets equal to b. So what we're going to be doing is that projection of ax down onto what the solution would be. So again, if I just tried to draw, so this was the span down here, this is ax. There's no solution for because it's not in the span down here. So what we're going to do is we're going to draw the projection down, and I'm going to find the ax hat, which is the closest to ax, because it's going to be the orthogonal projection. And what I'm going to do is I'm going to find out the distance, the length of this, right? That's going to be the b minus the a hat. The length of that will be how far off I am. And you know how you find the length of the vector is taking the sum of the squares. That's where the name least squares comes from. Okay. So the set of the least square solution coincides with the solutions from this normal equation. So I'm not going to go through the proof of this. It's a little beyond our scope. But if I'm trying to find the least square solution to this, I'm going to be finding the normal equations, which is multiplying both sides by A transpose. And so I know that A transpose A is, if I know that A transpose A is invertible, then I can find out what the x hat is by multiplying both sides by the inverse. All right, so here we go. Let's go do it. So let's first find A transpose. A transpose A, I should say. A transpose A. And let's just see if it's invertible, right? So A transpose will give me 1, negative 1, 0, 2. Negative 2, 2, 3, 5. And then times A, 1, negative 2, negative 1, 2, 0, 3, 2, 5. Okay, so if I multiply this 2 by 4 matrix times this 4 by 2 matrix, it's going to give me a 2 by 2. And it does. It gives me this matrix right here. Okay, so this normal equations, so the normal equations would be this A transpose A, right? A transpose A, like this right here, right? 6, 6, 6, 42 times my x equaling A transpose times my B. And the B they give me, right? Here's the B. 3, 1, negative 4, 2. Okay, so I'm going to multiply this side, right? So I get this 6, 6, 6, 42, x equaling, and if I multiply this 2 by 4 times this 4 by 1, I get a 2 by 1, so it's this. I just use my calculator. Okay. This is an invertible matrix right here. This is invertible, so I can go and solve for x. So solving for x, it's the determinant, 1 over 6 times 42 minus 36. So this gives me 1 over 216 times, right? And you switch these two and take the opposite of these two and then multiply it times this. So I'm going to leave the 1 over 216 outside and multiply these two things. And so then if I multiply that 1 over 216 in and use my fraction mode of my calculator, I get negative 1/3. 4/3, negative 1/3. So that is the solution. So that's, I'm saying x here, but it truly is x hat because I'm solving for the unsolvable, right? So x hat is 4/3 negative, 4/3 negative 1/3. Yeah, that's right. My messy one, negative 1/3. Okay, so that's my x hat. Okay, so how do I find the least squares error? So what that's going to be is that's going to be the length of b minus ax hat. So that's going to be that distance. So I need to first find b minus ax hat. And so b, 3, 1, negative 4, 2, minus a, 1, negative 2, 2, 5, and then times my x hat, 4/3 negative 1/3, right? X hat being the closest I could get to ax. And so if I multiply these, so 3, 1, negative 4, 2, subtract, multiplying these two this matrix times this vector gives me 2, negative 2, negative 1, 1. Okay, subtracting these two gives me 1, 3, negative 3, 1. Okay, so this is b minus ax hat. So the length of this vector is going to be what my least squares error is. So that's going to be the square root of 1 plus 9 plus 9 plus 1. So what do I get? 10 plus 10, root 20. So again, let me just kind of remind you. So here's my ax up here that is not down here in the solution set. So what I did is I found out what the hat is, what the ax hat is, found this, which is the closest to this because it's the projection by those normal equations, and then I found this distance by finding the length of that vector, and that was root 20. So we called that the least squares error. That's how much off I am in using this as an approximate solution to this.